Hey gang, coming at you with lesson 1-1 of your flipped video for 8th grade math. Guys, I need you to get to page 7 in that floppy book or your Math 8 textbook. We're going to be talking about rational numbers today. Our objective is twofold. We're going to determine if numbers are in fact rational, and then we're going to write rational numbers in different forms. Ultimately, we need to start with what a rational number actually is. And I'm going to be writing some stuff with my fancy pen. So if you see my arm moving, it's not just randomly moving. I'm actually writing some stuff down. All right, so rational numbers are numbers that can be written as a comparison of two integers expressed as a fraction. That's what a rational number is called. And they come in different forms. So rational numbers can be a percent. So we might have, for example, 25%. That's a nice one that we all know. The decimal format of 25% is 0.25. It's a decimal. We may have a fraction, again 25 hundredths, which anybody know what that is? Reduced all the way down, simplified 1/4. And then we could also have a mixed number as a rational number. Just because it's a fraction doesn't mean it can't have a whole number in front of it. So we could have like 1 1/4, for example. So all of these things are rational numbers. And again, rational numbers are numbers that can be written as a fraction. Sorry about my bad writing. So again, it says the root of the word rational is ratio. It says describe the relationship between rational numbers and ratios. Well, we can't write a ratio if we don't have rational numbers. So ratios are really the relationship between two rational numbers. So ratios are showing, it's going to take forever, the relationship between, BT means between, two rational numbers. Okay? If we're watching this at home, you can go ahead and pause if you need some more time to write that. If not, I'm going to go ahead and move on. Second slide. Guys, we're talking about rational numbers. Obviously, that's what our whole objective is about. And it says that in words, our key concept of rational numbers, a rational number is a number that can be written as the ratio of two integers in which the denominator is not 0. We are not allowed to divide by 0. You cannot have a bottom number of 0. You just can't do it. It's not allowed. And in symbols, that's this, a over b, where a and b are integers and b is not equal to 0. And then our model is this. We have rational numbers as all these on the outside. Within rational numbers, we have integers. Within integers, we have whole numbers. And then within whole numbers, we have natural numbers. We will talk more about the subsets of rational numbers and the real number system later. But what I want you to know at this point is I want you to know two things. I want you to know rocket with numbers. R stands for rational. I stands for integers. W stands for whole. And N stands for natural. And then I want you to know that because a rational number is a number that can be written as a fraction or a ratio of two integers, irrational numbers cannot be. Again, that's a review from 7th grade. You should remember that, but if not, it's a very, very quick review. Let's keep going. Now, every rational number can be expressed as a decimal by dividing the numerator by the denominator, top divided by bottom. So, the decimal form of any rational number is going to be called a repeating decimal. But if the repeating part is a 0, then that decimal is called a terminating decimal. And here's what it looks like in chart form. So let's say we have 1/2. Okay, we know that that's half of anything's 50%. The repeating decimal is 0.5000000. And see those 3 dots? That tells me that that last little number goes on and on and on and on forever. So this would have zeros going forever. Well, zeros don't really do a whole lot of anything. So it actually can terminate at 0.5. Just like this and this are the same thing. 0.5 is the same as 0.50. It's a terminating decimal. That 0 isn't doing anything for us. Same thing here. 2 over 5, or 2/5, is 0.400 repeating, or 0.4 as the terminating decimal. Now, here's where I'm going to throw you a loop. 5 over 6 is not a terminating decimal because when I do 5 divided by 6, I get 0.83333333. I know that those 3's go on forever because this dot 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 tells me so. Well, I can't do anything with the 3's. It doesn't, I never stop having 3's, so there's always going to be 3's. It's a non-terminating decimal or a repeating decimal, and we would indicate that with a line over the part that repeats. Let's practice. We're going to practice writing each fraction or mixed number as a decimal. Let's look at 5 over 8 first. Remember, we talked about top divided by bottom. This should be a no-brainer for you. So we're going to take 5 divided by 8 equals, and I got 0.625. So my answer here is 0.625. Here's the deal. It didn't tell me to round. It didn't tell me to move any decimal points. It didn't tell me to do anything. It just said write it as a decimal. Well, that's what I got. So I'm going to write the whole darn thing, 0.625. Number 2, negative 1 2/3. Okay, the book is going to tell you to do something weird. I would like for you to do it this way. All right, negative 1 is a whole number, right? So that's going to go in the whole number place or in the ones place. It's going to be negative 1. So I'm going to go ahead and put my negative 1 down. Negative 1 point. The 2/3 is the decimal part, so I don't know why the book is telling me to make all these extra steps when I don't have to do that. So negative 1 goes right to the left of the decimal point in the whole number place. Then I'm going to take 2 divided by 3. And I get 0.666, oh my goodness, 66666 forever, and then a 7. Again, spoiler alert, your calculator screen is only as big as it can be on the calculator, okay? The 6's go on forever and ever and ever. They repeat. So to indicate this repeating 6, I'm going to put a 6 here and tell everyone looking that that 6 repeats by putting that repeating bar there. The calculator has rounded for me by putting the 7. It has to. It's a calculator. It's only able to do so much. Okay, we can indicate repeating with the sign. All right, I would like for you to try these 4 problems on your own. Go ahead and pause the video, do them with your calculator, and we'll check them in just a second. Go ahead and unpause once you have all your answers. Okay. All right, let's check out what you got. In A, you should have done 3 divided by 4. In B, you have negative. You should have done 2 divided by 9. In C, you should have written 4 and then point, and then done 13 divided by 25, and then same thing on number D, 3 point, and then 1 divided by 11. You should have come up with the following answers. They're not there! What happened? What in the world? All right, so this one should be 0.75. B, I'll get my trusty calculator. Well, I can just do it right here. B should be, let's see, 2 divided by 9 equals 0.2. So this one you should have 0.2 with a line over it. Number C should be, I'm going to do 4, excuse me, and then 13 divided by 25, 0.52. So I should have 4.52. Again, nothing's repeating there. And then D, I'm going to have 3 point, and then I'm going to do 1 divided by 11. 1 divided by 11 equals, look at what I got. Check this out. Look at that. 0.09090909. The 09's go on forever. So that means I do not just put a bar over the 9. I got to put it over everything that repeats. So I'm going to put a line over the 0 and the 9. What? Awesome. All right, let's keep going. All right, number 3, here's a real world example. Okay, we're talking about baseball averages. In a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits at 530 at-bats. To the nearest 1,000th, find his batting average. It tells me in the book what to do. We're going to focus right here. Divide 175 divided by 530. Type it in your calculator as we go. I will do the same. 175 can you hear my dog barking? Divided by 530 equals, and I get this. 0.3301886 blah 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 blah. Same thing they got in the book. Now it's telling me to round to the thousandths place. So let me use red. Thousandths place is right here. We got tens, hundredths, thousandths. So this is all the numbers that I want to have in my answer. I have to look right here at this 1. 1 is not bigger, it's not 5 or bigger, so I'm not going to round up. I'm going to get rid of all of this stuff, and I'm going to be left with 0.330. Well, old Pujols had a pretty good batting average, didn't he? All right, let's head on out. Try it yourself. In a recent season, NASCAR driver Jimmie Johnson won 6 of the 36 races held. To the nearest thousandth, find the part of the races he won. Go ahead and pause the video, try it on your own, come back when you're ready. Okay, hope you paused. I'm going to try it. I'm going to do 6 out of 36. I'm going to do that in my calculator. 6 divided by 36. And I have this. 0, pen, come on. 0.1666666, and it goes on and on and on and on and on. So it's a repeating decimal. I'm rounding to the nearest thousandth, so I'm going to go tens, hundredths, thousandths. This is my thousandths place. I only want this much of my number showing. Look next door. It is 5 or bigger because that is a 6, so I'm going to round this up. Shout out if you know what number that's going to become. 7. Awesome. All right, so we are going to have our final answer of 0.167 races. You can box it out if you want. All right, next page. During a recent regular season, a Texas Ranger baseball player had 126 hits and was at bat 399 times. Write a fraction in simplest form to represent the ratio of the number of hits to the number of at-bats. Guys, it's really just asking you to simplify a fraction, which we don't really need to worry about that at this time, but I would like you to know at this point that you're going to put 126 on the top and 399 on the bottom. Ultimately, we're not talking about simplifying fractions today, so we're going to move on with life. Let's keep going. Next, all right, we are at the end. All right, guided practice, guys. Here's how we're going to check this tomorrow. I would like for you guys to do these 4 problems on your own. Use your calculator all you want to. Rewind the video if you need to. Go back and check some of the stuff that we've already talked about. And you're going to do questions 1, 2, 3, and 4. This is your entrance ticket tomorrow. We are starting here as your bell work. So you are going to have these done for me tomorrow when you walk into class. We're going to check them, and then we're going to move on with life and do our practice assignment. Okay? Sound good? Thanks for listening, guys. We'll see you on the flip side. All right. Bye-bye.